Apache mod_rewrite is a URL manipulation engine embedded inside the Apache HTTP server. It intercepts every incoming request, matches the URL path against pro-compatible regular expressions, and rewrites or redirects that URL before Apache maps it to a file on disk. Without mod_rewrite, Apache only serves the literal paths it receives. Critical detail. Mod_rewrite is not part of Apache core. You must explicitly load it with load module rewrite_module modules /mod_rewrite. So, in your server configuration. If that line is missing, the module is absent and every rewrite rule you write does nothing, silently, with no error. Once the module is loaded, the master switch is RewriteEngine On. Place this directive at the top of your htaccess or virtual host block. Without it, every rewrite rule below it is silently ignored. The module is present but disabled. Think of it as the power button for the entire rewrite system. Every rewrite rule has 3 parts. The pattern is a pro-compatible regex matched against the URL path. The substitution is the target string Apache will use instead, and it accepts back references like $1 through $9 to insert captured groups. The flags are bracketed modifiers that control behavior. For example, L means stop processing further rules and R equals 301 sends a permanent redirect. RewriteCond lets you gate a rewrite rule on an extra condition, typically a server variable, request header, or environment value. The rule only fires when the condition matches. You can stack multiple RewriteCond lines. By default, all must match, creating a precise filter between the request and the rewrite. An internal rewrite is invisible to the browser. The server substitutes the URL behind the scenes, maps the new path to a file, and serves it. The address bar never changes. An external redirect is the opposite. The server sends a 3xx response, and the browser issues a brand new request to the substituted URL. The R flag controls this. Omitting it means internal rewrite by default. Here is where mod_rewrite sits in the request pipeline. The client request arrives, URL path enters the rewrite rule chain, the substituted URL emerges, then directory index resolves directory requests to index files, fallback resource catches anything that still didn't map, and finally a handler serves the response. Mod_rewrite runs before all of these. Rules in the chain run top to bottom on every request. A match with the L flag stops further rewriting immediately. A match without L lets the next rule reevaluate the now substituted URL. This is why ordering matters. A greedy early rule with L can quietly hide every rule below it. Apache gives you 2 completely different places to write rewrite rules, and the choice carries real performance and security consequences. Understanding the difference between htaccess and httpd.conf is the single most important decision you'll make when configuring URL rewriting. htaccess is a per-directory configuration file. Apache reparses it on every single request that hits that directory or any of its subdirectories. That means every page load triggers a fresh file system read, a parse, and a merge with the server's master config. Multiply that by thousands of requests per minute, and you have a measurable per-request performance cost on top of a security concern. Any user with write access to a directory can override server-level directives. httpd.conf, or any file included by it like sites-enabled/000, default.conf, is parsed exactly once at server startup. Rules defined here are loaded into memory and applied directly with 0 per request overhead. Because this file lives outside any web-accessible directory, and users cannot touch it, you get full control, no allow override surprises, and the fastest possible rule evaluation path. Here's the gatekeeper most people miss: the allow override directive. Even if your htaccess file is perfectly written, Apache will silently ignore every rewrite rule inside it unless allow override includes file info. By default, many distributions ship with allow override set to none, which means your rules do nothing at all. The fix is in the main config. Allow override file info, and now htaccess rewrites are active. Now the 3 flags that handle the vast majority of real-world rewrites. First L last. When a rule matches and carries the L flag, Apache stops processing any further rewrite rules for this request. Think of it as a break statement. The match is final, the substitution is locked in, and execution exits the rewrite engine immediately. Second, NC no case. This makes the pattern matching case insensitive. A rule that says match.jpg will now match.jpg, .jpg, .jpg, and .jpg equally. Critical for image-heavy sites where Windows users and macOS uploads mix capital and lowercase extensions freely. Third, QSA, query string append. Without it, any query string on the incoming request is discarded the moment a rewrite fires. With QSA, The original query string is preserved and appended to the substitution. This is how you pass tracking parameters, referral codes, and session data through a rewrite without losing them. 2 flag combinations you'll see constantly. The canonical redirect. R equals 301 means stop processing and send a permanent redirect. Browsers and search engines cache 300 ones, so this is your SEO safe way to move old URLs permanently. The rewrite and keep query combo. A rule like RewriteRule page $index.php. Page equals home. QSA. Takes an incoming /page. Ref equals email and correctly produces /index.php. Page equals home and ref equals email. The page part rewrites, the ref perm survives, and locks it in. Before configuring redirects, you need to confirm Apache is actually installed and find out which version is running. We'll run a few diagnostic commands in sequence to gather that information before looking at live redirect behavior. The command Apache 2ctl, v2/dev/null httpd, v2/dev/null echo no Apache, probes for Apache across both Debian style and RHEL style installations, falling back to a clear message if nothing is found. The fallback chain ensures you always get useful output regardless of which distro you're on. Now we peek at the top of Apache's main configuration file to confirm mod_rewrite is loaded, and to see the active server settings. The 2/dev/null silences errors if the Debian style path doesn't exist, and piping to head -20 keeps the output manageable. With Apache confirmed, let's see real 301 redirect headers in the wild. The curl si flag issues a head request, silent mode with headers only, against hitbin/status/301 endpoint, which is designed to return a 301 moved permanently response. This is the key observation. The location. Header tells the client where to go next, and the 301 status code declares the redirect permanent. That's exactly what Apache's rewrite rule */new path R equals 301L would emit same status, same location header. Finally, we test an absolute redirect. Unlike relative redirects, this one sends the client to a completely different host. The location header contains a full URL, not just a path. This mirrors what you'd configure with RewriteRule https://newdomain.com R equals 301L. Apache and Jinx solve URL rewriting with fundamentally different philosophies. Apache scatters its rewrite logic across 2 places. A powerful engine called mod_rewrite that lives mainly inside httpd.conf, and a per directory file called htaccess that Apache consults on every request. Jinx rejects that model entirely. Routing in Jinx is declarative, centralized, and lives only in the main config inside location blocks. In Jinx, a typical front-end fallback to PHP looks like this. $files $$/index.php, $query_string. That single line tells Jinx to check the file, then the directory, then hand the request to index.php while preserving the query string. In Apache, achieving the same behavior with mod_rewrite requires multiple RewriteCond and RewriteRule lines, plus a RewriteEngine On directive, plus a fallback resource or directory check. Now the part most people underestimate: the performance cost of htaccess. By default, allow override is none, which means Apache never reads htaccess files at all. The moment you set allow override all, you pay a price on every single request. Apache walks up the directory tree from the document root down to the requested file, opening and parsing every htaccess it finds along the way, and comparing modification times to decide whether to reread them. Each of those checks is a stat, syscall. Each reread is disk I/O. On a deep site with 10 levels of directories, that is 10 file opens and 10 stat calls before Apache even decides whether to serve your image, your CSS, or your PHP script. Multiply that by every request, every asset, every favicon, and the cost becomes real. This is not theoretical. It is the reason shared hosting benchmarks collapse under traffic. The fix is simple and most people ignore it. If you control the server, never use htaccess. Put your rewrite rule and redirect directives inside a virtual host block or a directory block in httpd.conf. That way Apache reads the rules once at startup, caches them in memory, and never touches the file system again per request. htaccess exists for one reason only: shared hosting, where end users cannot edit the main server config. So here is the rule of thumb. Mod_rewrite is powerful but expensive when spread across htaccess. Prefer redirect and rewrite rule inside httpd.conf for any server you control. Reserve htaccess for shared hosting where it is your only option. And if you are starting fresh, look at Jinx *files first. One line replaces a wall of RewriteCons, and the performance question never even comes up.